ड्रिप स्पीड को तो जों सिगाङाव डिसकास खालामखाबाय ना ड्रिप स्पीड आरो मामला ड्रिप स्पीडआ मामला what is the drip speed actually what when electric field is applied across a conductor then electrons drifted in the opposite direction of electric field ना electric field नि opposite दिगथिंजाय मा जायो होनोमोनलाय इलेक्ट्रनफोरा दोरोदलाङो ना आरो बे दोरोदनायनि स्पिडखौनो मा होनो ड्रिप स्पीड ना दा बेयाव इलेक्ट्रिक कारेन्ट जों ड्रिप स्पीड जों रिलेशन ना what is the relation between electric current I and drip speed V okay so let us consider a conductor okay let us consider a conductor this is a conductor suppose okay this is a conductor okay and length of this is suppose L okay so this is phase A and this side is phase B if an battery is set there okay so this is positive this is negative okay so electric field is along positive to negative so this is the direction of electric field and this is the direction of what drift speed okay this is the direction of drift speed so let us explain it okay let us consider and let us consider a conductor of an electric field of length L and B length and electric field E is applied across it then the electrons drifted from B to A with drift speed B okay let N be what N be the total number of electrons across total number of free electrons across this conductor ना नैबे conductor थानाय free electron फोरनि number ना free electron फोरनि अनजिमा let N be the total number of free electrons inside the conductor what are you taken जों मा लाखो बेयाव n be the small n be the total number of electrons inside the conductor sorry we are not taking this as be the total not total number actually so it is small letter okay so let be the number of electrons electrons per unit area inside a conductor. Okay, small n is what? Number of electrons per unit area inside the conductor. So we will take capital N as total. Okay, so what we've taken, L be the what? Length of the conductor. And capital A is the suppose cross sectional area. You know what is the cross sectional area? Cross sectional area, mamla. Cross sectional area. Suppose this is a conductor. Okay, so you cut it perpendicularly, then you will get what? A small circle. Okay, so you can imagine that what is the diameter of this. So suppose diameter this. Okay, suppose this n portion is what? A circle. Okay, now area of this circle is what? Cross sectional area. You cut anywhere at any point, it will gives you what? Cross sectional area. Now then this will be what? Circular. Okay, जों बेखौ दानस'बा जेरैहाय माने एरिया मोनो ना बे बेंखन महरनि एरिया मोनगोन सर्कुलार एरिया देन दिस इज नोन एज व्हाट क्रॉस सेक्शनल एरिया बेखौ जों क्रॉस सेक्शनल एरिया बुङो एन्ड ए इज व्हाट क्रॉस सेक्शनल एरिया ऑफ द कंडक्शन क्रॉस सेक्शनल एरिया cross sectional area of the conductor. Okay, now therefore total number of free electrons inside the conductor. So earlier one what we have taken, this small area is the cross sectional area per unit. Okay, per unit area. Okay, cross sectional per unit area माने मोनफ्रोम square माबायाव unit area हमना ला meter square every meter square in every meter square number of electrons is what? Suppose small n, it may be what? 10, 15, 20, like maybe 100. Okay, so what will be total for all this cylinder? For all this cylinder it is suppose capital N. So you know number per unit volume, that means what? N, this is the number of electrons, okay, for per unit area. Okay, and this is what? AL means what? Volume. Okay, area into, so what is the volume of this cylinder? You know it, pi r square h. So instead of h we are taking what? L. Okay, you know volume of a cylinder means hasungni dublaitiya reza gaseb sunglai pi r square h. Instead of h what you should use? L. So it will be what? Pi r square L. So it is what? NaL. This is for what? Only for unit area. So this is for total unit area. So N means what? N means N by AL. N means what? Cross sectional area is what? Pi r. Here A is what? Pi r square. Okay, that's why this is. So AL means what? Volume. N means what? Number of electrons per unit volume. That means what? Total number of electrons divided by what? Total volume. So you will get for per unit area. Is not it? So if you again make this what? N equal to AL. Is not it? बुझबाय ना? बेबायदि जागोन जुदि स्मॉल n मामलाय number of electrons per unit volume बेबायदि जागोन ना बेनिफ्राय जों बेखौ मोननो हायो. So now what is the charge? Total charge. Okay, total charge inside the conductor. Q equal to what? We are putting negative sign here because charge of an electron is negative. Okay, so what is your number of electrons? N. And what is the volume? Volume is Al. What is the charge of an electron? E. That means what? 1.6 into 10 to the minus 19. Okay, so N means what? Number of electrons. So this is charge for a single electron. Okay, this is for single electron. बेयो माने सिंगल इलेक्ट्रन मोनसेल इलेक्ट्रन थाखाय E आरो जों हमना ला 10 थाबा 10 जों इनटु खालामगोन ना 11 थाबा 11 जों इनटु खालामगोन थिक बिदिनो N आ number of electrons. That's why this is the total. This represents total number of total charge, na, and this represents what? In a volume of this cylinder. Okay, so now next. This way, what? Now what you should do? Time taken by now time. Okay. Now time taken by electrons. Electrons to cross by electrons. To cross the length of the conductor. Time taken by an electron to cross from this point to this point is what? Suppose T. Okay, suppose this is the time T. So what will be this? This time taken is what? L divided B. Why? Because see here, B equal to, you know it, distance divided by time. L is what? Your distance. Okay, why it is distance? Because it is the length of cylinder. Huh? Then current, then the current I through the conductor. Through the conductor, na? Through the conductor is what? Current through the conductor I equal to what? Actually what? Q by what? Time. This is the rate of flow of charge. Okay. So what is Q? This one is Q. Okay. Minus NA LE. Okay. What is time? Time is what? L by B. Okay. Now minus NaLe into what? B by L. Yeah. So LL will cancel out. Remaining what? Minus NaBe. Okay. So next time what you should do? Now this is your current I. Okay, this is your current I. So you know number of electrons is fixed. This is not variable. Okay, number of electrons is fixed. Cross sectional area is fixed. It is not becoming larger, smaller. Na? गिरजालाय फिसा जालायथ' जायाखै. दा बेयाव मा जागोन होनबा बेबो फिक्स. ओमफ्राय B आ मामोनलाय ड्रिप वेलोसिटी ना? किन्तु मामोनलाय इलेक्ट्रन. चार्ज अफ इलेक्ट्रन इज फिक्स. ना? Charge of electron is fixed, but drip velocity may change. That's why what? I proportional to drip velocity. This is the relation between current I and drip velocity. Okay. Since N, A, N are constant. Okay, understood? So this is the relation between what? Current I and drift speed. Clear? So next, electron mobility. Yes. Electron mobility. Electron mobility, ini symbol apa? What is the symbol of this? Mu. Okay, this is mu. So what is the electron mobility? Drift speed equal per unit electric field is called the mobility of free electron. Mana mulai? Drift speed per unit electric field. Na, मोनफ्रोम electric field नि सानगुदियाव ना per unit electric field बेसेबांखिनि drift speed मोनो बेनो मामला electron mobility. So right definition: drift speed equal per unit volume per unit electric field na, per unit electric field is called the mobility of free electrons. Mobility of free electrons. So this is what? This is mu. Mu equal to, relation is what? Mathematical form. Mu equal to drift velocity, drift speed per unit electric field. Okay. Current density, na? Current density is represented with what? Capital J. So what is the definition of this? The current passing through unit area is called current density. माने मोनफ्रोम unit area नि गेजेरजों बारलांनाय माबाखौनो current खौनो मा होनोमोनलाय? Current density. So right, the definition: the current passing through unit area is called current density. Current density. If current I is distributed, suppose if current I is distributed uniformly, uniformly across a conductor of cross-sectional area A, then current density is J equal to what? I by A, where A is the cross-sectional area. Okay, by definition, what current density is current passing per unit area. So current divided by area, cross-sectional area. This is what your current density. So it is represented with what? Capital J. So you know what is the I from the earlier relation? Current I is what? NAVE. Okay, NAVE, and cross-sectional area A. So what is the V? Drip speed is what? Drip speed is equal to, from earlier derivation, we got the value of V. This is equal to what? E by M. M is the mass of electron, E is the source of electron, capital E is what? Applied electric field. Okay, and tau. What is the tau? Time. Time elapse. So what is the time lapse? Okay, time lapse. Time. This is what? Time required. Time within what? Two successive collisions. Na? Money sudaulainini successive collision ni time kono na be tau. Right? Madam like this E. Okay. So E will become what? E square. Okay. Now it will become what? Suppose we are writing N E square. E square by mass of electron M, tau electric field E. So what? It is a vector quantity. It is a vector quantity. Okay. It is a vector quantity. Okay. In a vector form. In vector form, what? Vector J equal to I by A. What? I is what? Actually, I is what? Scalar quantity. Okay. J is what? Vector quantity. So what will be the unit? Unit of current I is what? Ampere. Unit of area is what? Meter square. So ampere meter per meter square. Okay. Unit is ampere per meter square. So this is